Hello, this is Mario from ODEON. In this video, we would like to show you two of ODEON's visualization tools, which are 3D Investigate Rays and 3D Billiards. 3D Investigate Rays is a way to visualize ray tracing, allowing you to follow the full reflection path of each single ray. This is a useful tool to check whether your geometry is watertight or has unexpected holes in it. You can also confirm whether sound can propagate appropriately from your source's position. This is a tool available in every edition of ODEON. 3D Billiard visualizes sound as, you guessed it, billiards. This tool allows you to identify which surfaces are producing scattering, as well as acoustic effects such as flutter echoes and focusing. So, it can help people not familiarized with acoustics to understand propagation of sound. And like 3D Investigate Rays, it can also be used to find holes in the geometry. 3D Billiard is available in editions Industrial, Auditorium, and Combined. Now, let's go into detail about how to use these tools. You will find 3D Investigate Rays on the icon bar at the top. At the top right corner of the window, you have some options to trace the rays in steps or non-stop. You can step through individual reflections of a ray with the single forward button. At the bottom of the window, some informative values will update with each step. You can trace back with the single back button, though this will only recolor the reflection path without erasing it. You can run a full ray with the single ray button. You can run the visualization nonstop with the free run button. You can pause the visualization at any time. Then, you can continue the ray tracing with any of the previous options. You can reset the animation with this button. There are some additional settings you can adjust. You can select whether to use your surface's actual scattering, no scattering, or full scattering. This is useful to study how much difference it makes to have even just a little bit of scattering. Here, you can select which frequency scattering coefficient will be used. This dropdown only determines in how many frequency bands the spectrum will be split. Then, the second dropdown allows you to select the actual frequency. When a single central band is selected, you can only select 707 Hz, which is the logarithmic middle between 500 Hz and 1 kHz. This is also the default frequency on which the materialist scattering coefficient is applied. If you select 8 bands, then you can select any of the central frequencies of the 8 main octave bands. This number of rays is how many rays will be emitted from the source. A free run will stop once this number of rays is reached. At the end of the ray tracing, you can see the total number of lost rays. The maximum reflection order and the impulse response length will be stop criteria for each single ray, meaning a ray will stop reflecting once either of the two criteria is reached. Here, you can select which of your sources to use. You will see the selected source in red in the 3D view. The maximum damping is yet another stop criterion for each ray, in case you want to stop the rays once they have been attenuated by a certain amount. In some cases, especially small rooms, 3D Investigate rays may underestimate the number of lost rays compared to a job list calculation. This is because 3D Investigate rays has the maximum damping stop criterion, which the job list does not. So, rays in job list calculations can propagate for longer, which can give them more time to find holes in the model and escape. To understand the start at ray parameter and how it is different from just using less rays, I will explain the pattern in which the rays are emitted. Rays are emitted from the source following a spiral, first emitting upwards and working its way down. Increasing the number of rays will tighten the spiral and increase the resolution going down the path, but all possible directions will be evenly distributed. This is what the emitted rays look like without any reflections. By entering a number in the Start at Ray field, you will start from some point of this spiral. For example, if you're interested in looking at rays emitted horizontally, you could enter a number around half the total number of rays. With this checkbox, only lost rays will stay drawn, making them easier to identify if that's what you're interested in. This is how often the wireframe of the model will be drawn back on top of the ray tracing lines. This prevents the model from ending up hidden behind the rays. When the lines are drawn in the 3D view, they will all stay drawn as long as the model isn't moved. But if you rotate, zoom, or drag the model, only recent rays kept in the buffer will stay drawn. Switching windows can also cause earlier rays to disappear. This ray hits in buffer parameter is the maximum number of individual reflections that will be kept in memory, aside from the last traced reflection path. Rays vanishing when moving the model is usually not a big problem with a default of 10,000 ray hits in the buffer. But you can always increase it if necessary. Now, let's take a look at 3D Billiard. We will click on this 3D Billiard icon. As soon as you open the window, the animation will start with the default settings. Right now, the colors show reflection order. Again, you have some controls at the top of the window. The first button is to restart and run the animation. The second button restarts the animation but doesn't run it. This is especially useful to prepare to capture frames with our GIF animation tool, which we explain in our GIF workshop tutorial video. Then, the Run button starts the animation. This is also useful for resuming the animation from the current point after pausing without restarting the animation. While the animation is not running, you can advance in single steps with this icon. This dropdown allows you to select which source to use to emit the billiard balls. Here, you can select the plane in which the billiards will be emitted. These planes are absolute, but you can align the planes to the orientation of the source with this checkbox. For example, here, my source has some elevation. So, by clicking the checkbox, the planes will be tilted upwards. You can also emit billiards in random three-dimensional directions. Aside from point sources and array sources, you can also emit billiards from line sources and multi-surface sources. However, for these types of sources, only 3D random radiation is available. The surface scattering and scattering frequency options are the same as for 3D investigate rays. In ODEON Auditorium and Combined, you can define certain surfaces as reflectors. If you have done this, then you can visualize only the billiards that will bounce off reflectors. This is an alternate way of viewing reflector coverage. Defining surfaces as reflectors is explained in our tutorial on reflector coverage. You can toggle interior and exterior surfaces with the T shortcut. Here, you can change the number and size of billiard balls. This parameter is the distance traveled by each ball between each frame of the animation, which basically determines the speed of the animation. Ball size and distance per update are the only parameters that do not restart the animation. The maximum reflection order and maximum decay are stop criteria, just as we explained for 3D investigate rays. When a billiard ball reaches either, it will disappear from the animation. You can see how many billiard balls have disappeared in this dead balls counter. As previously mentioned, the billiard ball colors indicate reflection order by default. You can instead have the colors represent the remaining sound energy with the Show Absorption checkbox. You will also gain access to some other options. This checkbox is to include spherical decay, that is, the decay of sound due to propagation. But if you are only interested in the decay from reflections, you could leave it unticked. The absorption shown is broadband, which can be linear or A-weighted. You can also look at the absorption in a single octave band. Finally, here you can change the color scale. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!